Hello, welcome. Let us discuss and understand about Little's law in performance engineering. Before going into why this Little's law is required, how it can be applied in the performance engineering and performance testing, let us understand its concept using a coffee shop as an example. Imagine there is a coffee shop and arrival rate is 2. It means for every minute 2 users are arriving at the coffee shop, and assume arrival rate is 2. It means for every minute 2 customers are entering into the coffee shop, and they will each customer will spend 10 minute average time inside the system, that is average time inside equal to 10 minutes. Imagine each customer will spend 10 minutes in a coffee shop, that is average time inside is 10 minutes. And finally, once customer spends 10 minutes inside the shop, customer will depart, that is departure from the shop, right? This is arrival rate, this is exit rate. Here, if I want to measure at any given point of time how many customers will be there inside the shop, arrival rate and departure are in. If I want to measure at a given point of time how many customers will be there on an average in a coffee shop, then I can use the formula here, that is here L is number of users inside the coffee shop equal to lambda, that is arrival rate, lambda into W, the time customer spends inside the system. This is lambda, arrival rate. This average time inside the system is W. Then number of users inside the system. And if I want to find how many users are there inside the system at any given point of time, then I can use this particular formula. L is number of concurrent users, lambda is arrival rate, and W is average time each customer spends inside the system, right? This is called Little's law, and here Little's law is applicable in a steady state. Here steady state means arrival rate equal to exit, that is also called as throughput. Here steady state means arrival rate equal to exit rate, that is also called as throughput, because this equation holds true whenever a system is in steady state. It means there is a constant arrival rate, and there is the steady state means there is a constant arrival. Steady state means there is a fixed arrival rate. Also, there is a defined amount of time is spent within the system, and then user exits the system, right? If you consider during ramp up or ramp down time, this formula, if you take a ramp up and ramp down time also into, so based on this formula and numbers given here, we can calculate that arrival rate into time spent inside the system, that is 2 into 10, 20. At any given point of time in a steady state, you can find on an average 20 customers inside the coffee shop with this arrival rate and this much time inside the system. suppose if the arrival rate suddenly increases to 4, then it might cause a bottleneck here, right? If system is not able to serve more users, if system capacity already reached. Also, if suddenly the customer starts spending instead of 10-20 minutes, then also 20 into 2, 40 customers suddenly will be piled up within the copy shop, is beyond the capacity of the copy shop, then also it can cause a bottleneck, right? So basically here the Little's law formula states that average number of users in a system is equal to the rate at which users arrive multiplied by time each user spends in the system, right? Whenever the system is in a steady state, right? This is the concept of Little's law in performance testing and performance engineering. In the upcoming lectures, we will understand its significance, why it is used, and also how to implement it while doing the performance testing. Thank you for watching.